Okay, let's continue with the chapter 7 lecture, which is on the RTL design methodology. So for undergraduate, this normally is the last chapter that we cover. Chapter 8 normally we cover in the postgraduate course. So this should be our last chapter here on chapter 7 for the course of the semester. So chapter 7 is the main the main idea or the main content of the course, which is we want to be able to do a really practical RTL design. So this chapter actually combines what we have learned in the previous chapter 1 all the way to chapter 6. Okay, so it's a very important chapter. It's a practical design case study that we'll see. So so in this chapter we are going to go through basically we're going to go through in detail in 7.1, okay, all of that, 7.2, and also some example in 7.3, okay, and 7.4 we are going to skip. Okay, again, if you are interested, we have a postgraduate course that will cover in detail on what it means by the critical path delay and the maximum operating frequency. But for our undergraduate course, we're going to cover 7.1, 7.2, and 7.3. Okay, so let's go ahead and dive into the material here. So RTL Concepts and Terminologies, you can read this by yourself, but it's a very important concept that we need to understand, where in RTL, okay, so what does RTL stands for? So RTL actually stands for Register Transfer Level. Okay, let's see if we can find the terminology here. So RTL is basically the function level in design, in the digital design hierarchy. Okay, so it says here, so noting that the RT or TL is short for the level above the logic level. So I don't know if we can find here, but okay, so basically RTL, it stands for Register Transfer Level. Okay, Register Transfer Level, so RTL. So basically in RTL, register transfer means we have registers. Okay, and we have registers, and we are going to transfer the data between the registers. Okay, by using some control or based on some of our requirements, we are going to transfer the data from one register to another register based on the clock and reset of the registers. Okay, so so if we are able to do a register transfer, means that we can model a computer algorithm, because a computer algorithm basically is a sequence of steps. Okay, so first we want to do A, and then we do B, we do C, and during that operation we want to be in a certain state and also store some values. So that's what RTL is all about. And what we need to know for the course is basically the syntax that we are going to use. So the first syntax that we need to understand, if we go down here, is this one. Okay, so we have the SC RTL operation. So what it means, so S here is actually your state. Okay, so I'm in current state S, and C here is your control signals. Okay, let's say control signals, and here is actually your RTL process. Okay, or operations, you can say RTL process. So basically what it's saying here is, if we are in a current state, okay, let's say we are in a state, let's say it's a practical example, let's say we are hungry. If we are hungry, want to eat. So we are in a state hungry, and the control signal says food is available. Okay, we are hungry, and the signal say food available, and then the process will be eating. Okay, simple. So we are hungry, and the control says the food is available, then we can eat. However, if we are in the state hungry but there's no food, okay, then the RTL operation will be go buy food. Okay, maybe something else. So let's say we say hungry, no food, buy food. Okay, no food. Okay, no food. And if there's no food, so the process will be to buy food. Okay, so anything we can model like that. Okay, what is our state, what is the available control signal, I mean what is the current, can we do something, and based on that control signal, then we do the process, eating or go buying or do something. Okay, so that is what RTL is about. So it's about doing the process based on some controls and states. Okay, so in the practical digital design sense, we also have the RTL operations. Okay, so RTL operations is basically just a function of the registers. So basically we take the output of the register. Okay, so what is the registers here? We have R1, R2 to Rn. Okay, let's say we have 10 registers. We are going to take the output of the registers, do some processing on it. Maybe you want to add, minus, we can do a invert, put in some logic gates, do something, some function. Okay, so the F of the output of the registers, and then we are going to store inside RA. Okay, so that is the RTL operations. What we want to do, and once we have the result, we want to put it back inside the registers. Okay, so what are the operations that we can do to the registers? Okay, what are the RTL operations? So you summarize in this table here. So if we have X arrow Y like this, it means that we want to transfer the contents of register Y into register X at the end of the clock cycle. So basically what we're saying is Y goes to X. Okay, if you want to visualize the register, you can say something like this. Okay, so Y goes into X. So here is your X reg, here is your Y reg. Okay, so the Y is output Y, here is output X, DQ clock. Okay, so basically you can say that so this one is like this. So basically X arrow Y means that you want to transfer the content of Y into the register X. That's what you want to do. Okay, so that's that one, and X0 is we transfer 0. This is like a reset. You can say it's like a reset. Okay, clear the register X. Okay, X, Y plus Z. Okay, so what X, Y plus Z, how it's going to look like? So basically we have the Y register and the Z register. So you can say maybe something like this. Maybe I should get my notes here. Okay. Okay, so let's make it a little bigger. Okay. Okay, so if we have, for example, the RTL operation, and we have X arrow Y plus Z. So what is going to happen is going to transfer Y output, the output of the Y register plus the output of the Z register, and put it inside the X register. So we have obviously gonna have the X reg. I'm gonna put my X reg like this. Okay, the X reg is going to output X. Okay, and the input, okay, is going to plus. Okay, my Y reg, which is going to be output Y, and my Z reg is going to output Z plus and output. Okay, DQ clock. Okay, so here this RTL means that we're going to transfer the register content of Y plus the register content of Z and put it inside the X register. Okay, so that's that. And then we have other operations that maybe not so important for this course. In memory, we're not going to look at this one. Okay, the memory operations. Let's look at this one. This one is also quite interesting. Okay, so this one is basically we have the R1 register. Okay, so let's do something like this. Let's do R1 arrow R1 right shift. Okay, remember it's a right shift one. So right shift one. So basically what's going to happen is we have the R1 reg. The output is R1 and DQ, and we are going to shift by one. Okay, and put it inside. Okay, you see what's going on here. Basically, you are saying that this RTL operation is saying that we are going to get this one, okay, the output of the R1 register. We are going to shift it by 1, which is this one, and then we are going to put it back inside R1. Okay, so you can visualize something like this. R1 arrow R1 right shift 1. Okay. Okay, so other than that, you can see here you can also have this inside the RTL. You can also have ready equals to 1. So this one is actually coming from your control signal. We'll see more example later. And then this is setting the bus also. We're going to see more later. Okay, so let's see some example of the RTL statement. So if we look at this one, S0 A load load B into A. Okay, basically you can say in state S0 we're going to load B into A. Okay, so this one I think you already know. So basically I think it's quite simple. It's just saying that when we are in state S0, we are going to transfer the content of B into the A register. Okay, so this one is the second one is parallel. So in state 1 we do this and this together at the same time. So in state S1 at the same clock cycle, okay, or the same time, we are going to transfer Y, the content of the Y register into the X register, and we are going to transfer the content of B register into the A register. Okay, now this one is a little bit different. So this one is looking at the control. So here, so we can see that this one maybe we can get a new. Okay, so how to visualize this? SB. So when you're in state SB, which is a state that we cannot really see, so but we're saying that if we are in that state, we are going to check B. Okay, if B is true, then we are going to transfer Y into X. If B is false, we are going to transfer B into A. Okay, so we have basically we're going to have 4 registers there. Okay, so we have the X register and we have the Y register. Okay, and we also have the A and B register. So A register here on the right, B register on the left. So B register output B, A register output A. DQ. Okay, and now we are going to look at B. Okay, so basically you can just say that we're going to transfer, but then we also have the enable here. Okay, I'll put my enable down here. Okay, so if B is equals to 1, then you want to transfer X into Y. Sorry, y into X. Okay. Okay. So if B equals to 1, okay, B equals to 1, so let's say here is B is 1, then we are going to enable the X register, and therefore whatever is on Y is going to be put into X. Okay. However, if B is 0, okay, so let's say B is 0, then you're going to transfer something like this. So 0 here, this one will be 1, and here will be 0. So when B is 0, we are going to transfer the content of B into the A register. Okay, so basically we have a control there. Based on the current state, we're going to look at the control signal B. What is B? So based on the B, we are going to transfer certain values into a certain register. Okay, based on our control signal. Okay, so let's continue with this. So basically again we can have A dot B. Okay, we can check the A and B as our control signal. So here is our control. If A and B is true, then we transfer. Okay, let's quickly do this. I think it's quite straightforward. So basically what happened is you're gonna have the R2 reg Okay, it's output R2, R3 reg, it's going to output R3, DQ. Okay, and we have an enable there, and if A and B, okay, so if A and B, then only we will transfer the content of R3 into R2. Okay, so if A and B, so let's say for example if you want 1, right, and then we're going to transfer. Okay, but however if it's 0 1, 0 1, A is 1, B is 0, this is 0, no transfer. Okay, so here is no transfer. Okay, enable is 0, so no transfer. Okay, so let's continue. And basically here the last one also quite important. Go to SC, go to SB. So this means that based on the control signal P, okay, based on the control signal P, we are going to go to a certain state normally after we finish the RTL process. So once we have done the transfer to the register, we are going to go to a different state. Okay, I think we'll see more example of this one. Okay, so what else we have here? I think we're done for this part, and in the next part of the lecture we will look at one simple example of the RTL process.